Alright, it's John here again. It's getting kind of late, but I want to try to do Project Euler number 5, the smallest multiple. So it says 2,520 is the smallest number that can be divided by each of the numbers 1 through 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? Okay, so I've been thinking about this problem a little bit, and it turns out if you kind of build up from the bottom and say, okay, if we just start with say 1, then 1 is the minimum base case, okay, and you need a 1 to divide by. If you move and you say I have a 1 and a 2, then you really want to have a 2 to divide by, and then if you have a 1 and a 2 and a 3, then the answer basically is 6 that you have that is evenly divisible by all of those. And 1, 2, 3, 4, then you actually end up with 12 is the answer. 1, 2, 3, 4, 5. Then you come all the way up to 60. 60 is the first number that's divisible by all those. And you say 1, 2, 3, 4, 5, 6. And that one is actually still 60. 1, 2, 3, 4, 5, 6, 7. And then basically now you just end up having to do 420. So just sort of by kind of brute force thinking about it, you see there's this pattern that emerges where the next minimum number that can be divided by everything in the range is a multiple of the previous one. So I think what we can do here is we can sort of define a function that will use this information to discover the next value. Right? We can eliminate huge amounts of numbers by only taking multiples of previous answers. Okay, so the first thing we're going to do is we're going to define a test to make sure that we've got the right answer, right? So if we say I have this sequence 1, 2, 3, 4, 5, that it will find 60 is going to be the right number. And so my idea is basically what you want to do is take the remainder of a number right, we're going to divide our number by something. Let's say, so we're going to define a function test, and it's going to have a number, okay, and we're going to divide that number by this range. Okay, so we're going to say what we want to do is we want to map this remainder over a range. Let's do this case here of 1 through 5, which is range 1 through 6, or range 1 through 6. So if we map that, okay, so now we're going to have, when we execute this, oh yeah, let's see. Okay, we execute Yeah, we shouldn't do test. We'll do test multiple, so we don't overwrite something. Let's don't forget our hash here. Okay. Test m. So now we can do test m on 60. Okay, and it tells us 0, 0, 0, 0. So for 1, 2, 3, 4, 5, the remainder was 0, right? So we did 59. Then we have remainder 0, 1, 2, 3, 4. So what we want to do is, in our test, we want that to be all zeros. So what we could do is, could reduce that, and then just check to see, is that all equal to 0? Okay. Yeah, equals 0. So 59 should not be correct, whereas 60 is correct. Okay, so that was this case 1 through 5. So we want to make another parameter here, which is what's our range? So I want to actually put in a 5 here and then get a 6 here. So I'm just going to do an increment of r. Okay, so now we can do test m. So we're testing whether 60 works up to 5. So that should be true. Define that. Okay, so that's true, and then it should actually work for 6 as well. Okay, good. So we have a way to test everything. So we can make a function that just starts testing to see what number works, right? So we have our test. Now we can do a find. So let's do define a function find m, where we're going to take in the range that we're looking for, and we're going to find a multiple that works for that. So we're going to do the range from 1 until r. And let's do the same trick. We'll do our increase r so it's inclusive, makes it feel more natural to me. Okay, so we have 1 through r, and so let's map our test function over that range, and what we need to do is pass in the current value and then the range that we're going over. Alright, so we have that. So let's try that out. We're going to find m there. Okay, find m, and we're looking for through 5. Let's just try that out. False, 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 false. Sorry. We need to make this a lot bigger. Let's just, it needs to just be a gigantic number. And then we need to find the first value where that works. Okay. So we can drop while, and then we need to invert our logic here. I'm going to make that not equal. And then we can drop while, and we can go over some range. So let's not get too crazy yet. Let's go to 1,000. And we can try that out. Okay, so there we go. So we got 60 is the first answer. So we need to go do a first here, so that we get only get the answer that matters. Alright, so now we say we're going to try to find for the range 1 through 5, what's the first smallest number that can be divided by everything 1 through 5. Okay, so now we want to do our trick where we also pass in the previous multiple. So let's pass in our multiple here. And what we'll do now is in the range function, we'll start from 0. We're going to end somewhere huge. And then we're going to take steps of the previous multiple. So we're going to take the previous answer. Okay, so in this case, find m for 5. The previous multiple was 12. So we can do find m 12. So evaluate that, find m. Oh, we got 0. Okay, because I forgot, when we do this range starting with 0, it's going to start with 0, which is sort of a degenerate case. It's going to mess us up. So we need to drop 1 here. Try that again. That is not right. Why is that so wrong? Okay, range. Okay, go start, end, step. So we're going to start with 0. We're going to end somewhere huge, and we're going to take steps of multiple. So it should be if we do range 0, 1e to the 100 by multiple of 12, and that gives us that, and then we do drop 1, so that gives us 12, 24, 36. It seems like that should be correct. So so then our first value 12. Oh, let's just do this. Let's stop at the same value, 100. Try that again. We get nil. confused by that. Let's see. So we're going to drop 1, and then that goes into our test function. So let's just throw a little debug step in there. Print a string N and R. Print line. Print line debugging. Okay, so what's going on here? So it calls our, I think we have some, what are we doing here? Yeah. Let's change this up. R and multiple. Got arguments backwards. Multiple. Okay. There we go. So now we can get rid of that. Sorry about that. Shouldn't do this at 12:40 in the morning. That's not productive. Okay, so we now have the ability to find the next based on a multiple. So now we can define our final function. Let's see if we can do this for us. So we're going to say defin smallest, and we will take our range in that we're trying to get to. Okay, so we will loop, and we're going to build this up from the bottom. So we're going to say we're going to have n and 1, and then we're going to keep track of this last multiple, and so we're basically saying 1 1. Our multiple is going to be 1 and our n is 1 as we start this loop and we build up. Okay, so when do we stop? We stop when n is greater than our range. Okay, so when n is greater than our range, then we will return our multiple. Otherwise, we're going to recur. But let's define things. So let's say let's run our find m function here. So we're going to say our next multiple is equal to find m from our current range, which is n, and our last multiple mult. Okay, that'll be our next multiple, and we can, at this point, go ahead and recur back to our loop. So the first thing is the n, so we're going to inc in, and then we will pass in the new the next multiple. Okay, let's look at that again. So we have a function smallest. We're going to make a loop. We're going to initialize it at the bottom, n equals 1, and our multiple is 1. Our base case says if the current range is bigger than the target range, then we're done. Give us back the last multiple. Otherwise, calculate the next. which is the findIn function, and take that next and pass it into recur with the incremented next range value. Okay, let's try that out. Smallest. Okay, so let's do smallest 5, 60. Smallest 6 should also be 60. Smallest 7 is nil. Okay. We have a bug here because we stopped here at 10. So let's stop at 10. Stopped at 100. Alright, let's stop at 1 billion. Try that again. Smallest 7. 420. Great. Alright, and let's see, from Project Euler, they gave us 10 as the test case. And that gives us 2520. So now we can run it with 20. And we get 232792560. Copy, paste. Okay, 78731, and cross our fingers. The confirmation code is not valid. Okay. Paste. 57958. Try again. Alright, we got it right. Even at 12:45 in the morning. So, thanks for watching.